Alright, guys, when we look at groundwater, that's what we're looking at today. Well, we should go ahead and go back over some of the percentages again, just kind of driving this home again where all the water is. And we remember, just kind of remind ourselves that the oceans make up over 97% of all the water on Earth. So really that is where all of our water is. We actually have very little that's available for us to use, either as drinking water, as cooking water, etc. So we look at our atmosphere, and most of you guys woke up this morning with a nice little thunderstorm with some rain. Okay, so that's our atmospheric water that's sitting up there. That makes up less than 1/1000% of all the water on Earth. And then we have almost a 1/10 of a 100% that's locked up in the fresh water. And then our ice caps and glaciers pretty much make up the remainder of our amount. And we have this tiny little fraction that's rivers and streams. And then we get this 1/3% that is groundwater. So 1/3% of all the water on Earth is locked into the ground. Now who can tell me how that water gets into the ground?
Infiltration.
Infiltration, okay, that's the process by which precipitation becomes groundwater through infiltration. How does it infiltrate the ground? Brandon? How does it seep into it? What does it need? Yeah, we need to have some air spaces in the soil. Okay? Exactly. So, when we think about these things, what affects the rate of infiltration? We're going to talk a lot about that, right? We talked about porosity of the rock in the soil. Is it loose soil? Is it compacted soil? We've talked about things like slope and how that affects the infiltration rates. Remember, if we have a high slope or a very steep slope, we have very little infiltration. But if we have a near flat slope, we usually have a pretty good rate of infiltration. We talk about porosity, compacted versus loose soils. Also allow for infiltration. And Brandon, you brought up a good point here with soil types. Clay versus sand. Now, has anybody ever had or felt clay soil before? Yeah, it's very hard, right? Very grainy. But as soon as you put water on it, what happens to it? It's very soft, but it almost becomes as a protector. Right? The clay, what happens is you have these very loose, very thin things of clay. You think of it as like tiny little flakes of clay. And the problem with clay is when it's dry, it shrivels up. How many of you guys have ever seen pictures of mud cracks in the desert soil? And you might have seen them around here too. It's when that clay dries, it contracts. And that's how you get the mud cracks. It literally keeps contracting into the center and then it cracks and you get these little polygon shapes all over the ground floor. With water, all of a sudden these little flakes of clay act like rice. What happens when you put rice in water? What does it do? It enlarges, right? That's why rice actually is a really, if you guys want a diet, that's the thing to eat is a lot of rice. Because it'll expand within your stomach and convince you that you're full. So it actually doesn't take that much rice to fill you up. It's a really good dietary supplement. Yes?
But if you're a wrestler, you're not supposed to eat rice.
Why are you supposed to eat rice as a wrestler?
Because when it expands and absorbs the water, you won't lose the water as fast. It'll cause you to gain weight instead of lose it.
Just don't eat it before.
So it's better to starve yourself? That's a good plan. I like that plan.
I don't have to starve myself. I'm already like.
Alright, so anyways. So like rice, the clay absorbs the water and it expands. But when it does that, it expands and starts filling in these gaps. And as it does that, there's nowhere for the water to seep through. So now the water comes in, and there's no air pockets for it to infiltrate. And so this is what we call an aqua fluid. An aqua fluid is a barrier that prevents water from being able to move through it. So if you have clay soils, a lot of the times the water will just sit right on top of your ground and get some flooding in your yard. If you have sandy soils, the water will simply just drain right through the sand. Through your reading, what did you guys learn? Where do we store groundwater? And where is it stored? We store it in these gigantic tanks? Where is it stored at?
Caves.
Could be in caves. Aquifers. Aquifer. Well, hopefully. Otherwise, there's water in there. So an aquifer is nothing more than a layer of supersaturated soil that is supersaturated with water. That's all it is. So it's not like there's this big underground lake. All it is soil that is completely saturated with water. Then all we do is literally drill down into the ground and put a straw through the hole and suck the water out. And that's literally how your pumps work. All you're really doing is drilling into the aquifer and then sucking out the water. Very simple process. Now, one of the things that's kind of interesting here. Sorted environment, what all your air pockets? Yeah, there's no room because now all the smaller pieces have filled in that room. So well, this is actually where a lot of times when they start putting in basements, they'll put in a layer of pea gravel, and all that really is that's well sorted material. It's all ground relatively the same size, and allows the water to drain right through them. Whereas if you had poorly sorted gravel, there's no space for the water to go, so it would just sit on top. So that's one of those other characteristics. In your reading, you should have came across 3 terms. One is water table, zone of saturation, and zone of aeration. Before I talk about the water table, it's important for us to talk about the zone of saturation versus aeration. What is the zone of saturation? Anyone?
The water.
Okay. What does it mean to be saturated?
It means that when like you take a sponge that you like wash dishes with, or like a
Yeah.
sponge, and nothing else can be put into that because there's too much water already in there, so it's all saturated.
So what's the zone of saturation?
Place where the water will be completely full of water.
There you go. Perfect. Every layer of soil has a certain amount of airspace within it. The zone of saturation is that layer of ground where all the available air spaces are completely filled with water. So as you can see, this is definitely a soil. But it's not completely liquid. Okay, so Sue said, I like exactly what Becca said. It's like the sponge. Okay, it's completely full of water. Still a solid sponge, but all the open air spaces are filled with water. Now, what does it mean to be aerated? You guys heard that term before? What does it do? It doesn't keep it purified, but it does keep it, basically, to aerate means to put oxygen. Okay, it's putting air in the ground. So the zone of aeration is where we have water that comes down, right? We have rain that comes down onto the ground. And then the water trickles its way through the zone of aeration. So that's your zone of aeration. Again, the water is somewhat there, but it's not stored there. It's simply passing through the zone of aeration. The saturated soil is underneath your zone of aeration. And then finally, we talk about the water table. And all the water table is, guys, is the boundary between them. That's your water table. It is the depth at which you finally hit the zone of saturation. The 3 bullets I want you guys to write down, and this will finish up our notes for today. First, groundwater moves in the same direction as the slope of the land. So if you're going downhill, the line bodies will run parallel with the slope. The movement of that water is very, very dependent on the permeability of the rocks. If the rocks aren't permeable, meaning you can't pass through it, the groundwater is going to stop moving. As we've already said before, the large storage of water underground is called aquifers. So that pretty much concludes our notes.